Hi, welcome to my channel pibyme Maths. This is by Vasdevan. In this video, we are going to be solving January-February 2025 for the Pure Math 1 past paper. Let's look at question number 1. Part A, we have a matrix given. Determine the determinant value of P in simplest form in terms of P. To find the determinant value, you multiply the elements in the main diagonal. So you write it as determinant value of P is equal to P times P minus 1 minus, it's always minus, the elements in the other diagonal, which is minus 3 times, so it becomes plus 3 times P plus 1. So you simplify, you'll get P square minus P plus 3P is 2P plus 3. That's all. Hence, show that P is non-singular for all values of P. If a determinant value of a matrix is 0, that's a singular matrix. If the determinant value of a matrix is not equal to 0, it's a non-singular. That's a condition. So we have to prove that the determinant value, that means this will not be 0. So for part B, we write determinant value of P is equal to, this is the determinant value, right? So I'm going to apply completing the square here. So I'm going to get P square plus 2P, half of 2 is 1, so plus 1 square minus 1 square plus 3. So I will get P plus 1 whole square. This is minus 1 plus 3 is 2. So this value will never be 0, because think about it, even this whole thing becomes 0. If let's say P is minus 1, this becomes 0, right? But plus 2 will always give you a value, it will not be 0. So you need to write P plus 1 whole square is greater than or equal to 0. Therefore, determinant value of P is not equal to 0. Therefore, P is non-singular for all values of P. This symbol is for all actually, or you can just write for all real values of P. Now part C, find the P inverse. It's a 2 by 2 matrix and it's very easy to find the inverse of P. The inverse is, we can straight away write P inverse is equal to 1 over the determinant value, which is P square plus 2P plus 3. And then we need to write a matrix. In this matrix P, we swap these two elements. So it's P and P minus 1, P and P minus 1. And then the other two elements, right? We invert the sign of these two elements. Change minus 3 to plus 3. This P plus 1 by minus of P plus 1. So it's going to be plus 3 minus of P plus 1 or minus P minus 1. So you can just divide each element by this determinant value. So P over P square plus 2P plus 3 minus P minus 1 over P square plus 2P plus 3. 3 over P square plus 2P plus 3. P minus 1 over P square plus 2P plus 3. That's the inverse matrix. That's all. Question number 2. We have a function given where x is positive. Show that the function f of x equals 0. The equation has a root alpha in this interval. So it's very simple. We just need to sub in these values into the function. So find the value of f of 0.3, which is 0.3 square minus 7 times 0.3 minus 4 square root of 0.3, everything divided by 0.3 cubed. And then f of 0.4 is 0.4 square minus 7 times 0.4 minus 4 square root of 0.4, everything divided by 0.4 cubed. Let's get these values first. So 0.3 square minus 7 times 0.3 minus 4 square root of 0.3 divided by 0.3 to the power 3. 3.456 dot dot dot. It's a positive number, right? I'm going to change 0.3 to 0.4 now. Zero 0.4 square, 7 times 0.4 minus 4 square root of 0.4 divided by 0.4 to the power 3, which is a negative number, negative 4.0615 dot dot. So the value is value of function at 0.3 is a positive number, at 0.4 it's a negative number, so there is a change of sign. So you need to write the conclusion, there is a change of sign, there is a change of sign, and you need to write this also, f of x is continuous. Therefore, what does that mean? If the value of the function changes from positive to negative or negative to positive, that means the curve representing this function crosses x-axis between these 2 points. That means there is a root. So therefore the root alpha lies in the interval 0.3, 0.4. That's all. That's the conclusion. Part B now. Determine f dash of x. So I'm going to write f of x first. F of x is x square minus 7x over, I'm going to divide each term by x cube by keeping the negative as a common negative. 7x over x cubed minus 4 root x over x cubed. So it's going to be x square minus, you cancel x and x, this becomes square, so put it on top, it's going to be minus 7x power minus 2, and then negative times negative positive 4 square root of x divided by x cubed becomes x power half minus 3, which is minus 5 over 2. Now differentiated, x square becomes 2x. When you put minus 2 in front, it's going to be 14x power minus 3 plus 4 minus 5 over 2 x power minus 5 over 2 minus 1. And then simplify it, you will get 2x plus 14x power minus 3 minus 10x power, because when you cancel this becomes minus 10 actually, minus 10x power minus 7 over 2. That's all. It's a 3-mark question. Let's move on to part C now. Using x naught is equal to 0.3 as a first approximation for alpha, apply the Newton-Raphson procedure. What is the Newton-Raphson procedure? The iteration. xn plus 1 is equal to xn minus f of xn divided by f dash of xn. You don't have to memorize this. This is given in the data booklet. So to write x1, if you replace n by 0, it's going to be x naught minus f of x naught divided by f dash of x naught. So it's going to be 0.3 minus f of 0.3, which we know already from part A, but unfortunately we haven't stored the value actually, so we need to calculate it again, because you need to use the actual value with all the decimals here, divided by f dash of 0.3. so that means you need to sub in 0.3 into the f dash also. If you want, you can write one more step, 0.3 minus, write f of 0.3. In f of x, replace x by 0.3. 0.3 is CAIE minus 7 times 7x minus 4 root of x divided by x cubed, and then f dash is 2x plus 14x power minus 3, 14x power minus 3 minus 10x power minus 7 out, x power minus 7 out. That's the second approximation. Because this is a first approximation, they want us to find the second approximation to 3 decimal places. So let's calculate this value. So what I'm going to do, okay, since we have this here, I'm going to change this to 0.3, 0.3 minus 4, 0.3 divided by 0.3. You'll get 3 point something. I'm gonna store the value as a. Okay, so this value I have stored it as a. Now let's find the denominator, f dash of 0.3 now. 2 times 0.3 plus 14 times 0.3 to the power minus 3 minus 10 times 0.3 to the power minus 7 over 2, which is minus 3.5. Okay, I'm going to store this value as b. I stored this value as b. So let's calculate everything together now. So 0.3 minus a over b. 0.322, they want the answer to 3 decimal places, so the answer is 0.322 is the answer. That's all. Part D now. The f of x, the equation f of x equals 0 has another root beta in this interval. Use linear interpolation once in the interval to determine the approximation for beta. Okay, let's say this is x-axis and the point 1.3 is here, 1.5 is here. Let's find the value of f of 1.3 first and then f of 1.5. That means in this function f of x, where is it? In this function f of x, replace x by 1.3 and 1.5 and get the values. So 1.3 is going to be, okay, let me write the function here. It's f of x is equal to x square minus 7x minus 4 root x over x cubed. So f of 1.3 is 1.3 square minus 7 times 1.3 minus 4 square root of 1.3 divided by 1.3 to the power 3. You get a negative number, so I'm going to straight away store this value as c. Wait, what did I do here? I store this value as c. Okay, it's minus 0.376. Minus 0.376. Now let's find f of 1.5. 1.5 squared minus 7 times 1.5 minus 4 square root of 1.5 divided by 1.5 to the power 3 is a positive number, 590 something, 0. I'm going to store this value as d. 590 something, a positive number. So that's the first thing you need to do. Find the value of the function at these 2 points. We stored this as d, just put a little difference so we won't mix up ABCD. Okay, so for f of 1.5, the function value is positive. For 1.3, it's a negative, right? So let's connect these two and let's assume this is beta. It's in between these 2 points. This length is f of 1.3. This length is basically a negative number. So when it comes to length, you need to put another negative sign. This is minus this. This length is positive number, so you don't need to put a minus. F of 1.5. And we are going to apply linear interpolation. It's like similar triangles, you know. So this length divided by this length, which is f of 1.5 divided by this length is 1.5 minus beta, will be equal to this length divided by this length. So this length is, since it's a negative number, you need to put another negative, minus f of 1.3 divided by this length, beta minus 1.3. That's the linear interpolation method. Now just cross multiply, make beta as a subject. And then finally at the end we are going to sub in the values here. So when we cross multiply, f of 1.5 times beta minus 1.3 times f of 1.5 is equal to, cross multiply these two. So we'll get f of 1.3 times beta minus 1.5 times f of 1.3, right? And then make beta as a subject. So to make beta as a subject, I'm going to move this term here, this term here. So when I move this term here, the one involving beta, and take beta as a common factor, I will get f of 1.5 minus f of 1.3 times beta is equal to 1.3 times f of 1.5 minus 1.5 times f of 1.3. So beta is equal to, so this is when we are going to bring this term to the denominator, but show this step this way using the values of f of 1.3 and 1.5. So 1.3 times f of 1.5, we stored it as d, 0.590 dot 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 minus 1.5 times the value of f of 1.3 is a negative number, so you can just put it this way, minus 0.376 dot 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 divided by this one will come to the denominator, right? So f of 1.5, which is 0.590 dot 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 minus f of 1.3 minus 0.376 dot dot dot. But in my calculator I stored the value as c and d. I need to know which one is c. F of 1.3 is c. Okay, so what I'm gonna do, 1.3 times d, d is f of 1.5, minus 1.5 times c divided by d minus c, d minus c. I got the answer already. They want the answer to 3 decimal places, so the beta is equal to 1.378. That's how you apply the linear interpolation. Make use of the stored value in your calculator. That's all. Question number 3. The quadratic equation 3x square minus 2x plus 5 equals 0 has roots alpha and beta. Without solving the equation, write down the value of alpha plus beta and alpha times beta. Always remember this, when you have a quadratic equation in this form and it has two roots alpha and beta, the sum of the roots will be minus b over a and the product of the roots would be c over a. So in this case, alpha plus beta is a is 3, b is minus 2, c is 5. So b minus b over a is minus of minus 2 over 3 is 2 over 3. And the product of these roots will be c over a. That's all. Part B now, 2-mark question. Find the value of alpha square plus beta square. You can write alpha plus beta whole square as a square plus 2ab plus b square, right? Sub in the value of alpha plus beta here, which is 2 over 3 whole square is equal to, keep these two as it is, 2 times alpha times beta is 5 over 3. That's all. Move this value here, you got the answer already. So it's going to be 2 square over 3 square minus 2 times 5 over 3 is 10 over 3 minus 26 over 9. Alpha square plus beta square is minus 26 over 9. That's all. Part C, it's a 4-mark question. Determine a quadratic equation that has 2 roots, this and this. So to find the quadratic equation, we are going to find the sum of the roots and then the product of the roots. Let's find the sum of the roots. Alpha plus 1 over alpha plus beta plus 1 over beta is, you can write this as alpha plus beta, keep it as it is, plus 1 over alpha, 1 over beta. So keep alpha plus beta as it is because we know the value of alpha plus beta here, right? We can use this value. Okay. Now combine this by cross multiplying. So you will get beta plus alpha divided by alpha beta, right? You multiply, cross multiply, multiply these two. And then replace alpha plus beta by the value 2 over 3. So 2 over 3 plus 2 over 3 over alpha beta is 5 over 3. So it's going to be 2 over 3 plus 3 will be cancelled, 2 over 5. 16 over 15. We got the sum of the roots already. Now let's find the product of the roots. The product of the roots, alpha plus 1 over alpha times beta plus 1 over beta. So I'm going to take alpha and multiply both. So I will get alpha beta plus alpha over beta plus. Take 1 over alpha and multiply both. So beta over alpha plus 1 over alpha beta. Here we can use the value of alpha beta, so we don't need to worry about these two terms. And the middle two terms, right, these two terms, I'm going to combine them by cross multiplying. So keep alpha beta and plus 1 over alpha beta as it is. When we combine them, we will get cross multiply these two, alpha square plus beta square divided by alpha beta. So we can use the value of alpha square plus beta square from part B of the question. We got it as minus 26 over 9, right? So I'm going to use all the known values here. Alpha beta is 5 over 3. 1 over alpha beta is going to be the reciprocal of it, plus alpha square plus beta square minus 26 over 9 divided by 5 over 3. We'll get this answer. So 5 over 3 plus 3 over 5 plus minus 26 over 9 divided by 5 over 3. 8 over 15. So that's the first thing you should be doing. You need to find, whenever you are given two roots, find the sum of the roots, get the value. And then find the product of the roots, get the value. Now using the sum of the roots and the product of the roots, you can write the quadratic equation already. The quadratic equation is, always remember this, it's x square minus sum of the roots times x plus the product of the roots is equal to 0. So x square minus sum of the roots, we got it as 16 over 15x plus 8 over 15 is equal to 0. But again, go back and read the question. It says they want the equation in this format where PQR are integers. You cannot give any fraction. So multiply throughout by 15. 15x square minus 16x plus 8 is equal to 0. That's the required quadratic equation. Question number 4. F of z is equal to 6z cubed plus az square plus bz plus c, where a, b, c are integers. Given that this is a complex number, is a root of this equation, write down the other complex root. If you have one root as a complex number, the complex conjugate pair will be the other root. Therefore, the other complex root is z is 2 over 3 minus change the sign of the imaginary part. That's all. Part B, a 5-mark question. Given that z is equal to minus 3 over 2 is also a root, determine the values of a, b, c. So we have two roots, right? I'm going to find the sum of the roots first. So 2 over 3 plus square root of 17 over 3i plus 2 over 3 minus square root of 17 over 3i. So these two terms will be cancelled. 2 over 3 plus 2 over 3 is 4 over 3. And then I'm going to find the product of the roots first. Product of the roots now. A plus b times a minus b. It's going to be a square minus b square. So 17 over 9 I square. We know I square is negative 1. So we are going to get 2 square over 3 square plus 17 over 9. That's 7 over 3. So we can, using these two roots, we can write the quadratic equation as z square minus sum of the roots times z plus the product of the roots. Right? Now, since the question says this also another root, I can write the function first. 6z cubed plus az square plus bz plus c is equal to this quadratic function z square minus 4 over 3z plus 7 over 3 times, write this as a factor, put this number here, z plus 3 over 2. But there is a problem actually. When we multiply these two, we are getting only z cube, whereas it has to be 6z cube. So you have to put a 6 in front. So 6 is 2 times 3. I'm going to multiply first factor by 3, second factor by 2. So I'm going to get 3z square minus 4z plus 7. And then 2z plus 3. If you don't understand what's happening here, this 6 is basically 3 times 2. So I take 2 and multiply this factor, 3 and multiply this factor to get rid of all the fractions, which is equal to 6z cubed plus az square plus bz plus c. Now compare the coefficients to find ABC. I'm going to compare the coefficient of z square now. Here it's a is equal to, when you multiply these two, you're going to get 9. When you multiply these two, you're going to get minus 8. So a is equal to 1. And then compare the coefficient of z now. B is equal to minus 4 times 3, which is going to be minus 12z. So the coefficient of z is minus 12. 7 times 2 is 14 plus 14. B is equal to 2. And then you can compare the constant term and replace z by some value. I'm going to replace z by 0. So this is 0. C is equal to, these two terms are 0. 7 times 3. C is equal to 21. That's all. We got the values of A, B, C. Part C now. Show all the roots of the equation f of x equals 0 on a single organ diagram. Okay, the roots are, the first one is this. So the three roots are, this is the first one, 2 over 3 comma 17 over 3, square root of 17 over 3. So let's draw the diagram. This is the imaginary axis, this is a real axis. So write it as real part of Z, or just write real axis, imaginary axis. This is O. And then 2 over 3 square root of 17 over 3. Okay. Square root of 17 over 3 is 1.37. 2 over 3 is 0.6. Okay. So let's say 2 over 3 here. This is here. So this is 2 over 3 plus square root of 17 over 3i. Just draw a line from origin to this point. And then draw a reflection of the line here. That's going to be 2 over 3 minus square root of 17 over 3i. And then there is another root here. Z is minus 3 over 2. So only the real part, the imaginary part is 0. So it's gonna be, it's gonna be here minus 3 over 2. That's all. You'll be given 2 marks for this. Let's move on to question number 5. Use the standard result for summations to show that for all positive integers n, this is equal to this. So I'm gonna take this first without the sigma notation and open the bracket. R times r square plus 5r plus r plus 5, which is gonna be r cube plus 6r square plus 5r, right? So sigma r is equal to 1 to n, r times r plus 1 times r plus 5. Use the expanded one, r cube plus 6r square plus 5r, put it in a bracket. Split the sigma notation. So it's going to be sigma r cube plus 6 sigma r square plus 5 sigma r. The limits are r is equal to 1 to n. In your data booklet, you have a result for this and this given. So I'm going to use the results now. Okay. So this is going to be, the result for this is, result for this one which is not given in the data booklet, it's sum of n real numbers. So natural numbers is n plus n times n plus 1 over 2. And if you square the whole thing, that would be the result for sigma r cube, which is n times n plus 1 over 2 whole square plus 6 times. The result for sigma r square is, which is given in the data booklet, 1 over 6, okay, n times n plus 1 times 2n plus 1. And then 5 times the result for sigma r, that's the only thing you should memorize, n times n plus 1 over 2. Now we need to simplify this and write it in this format. So if you look at all the three terms, probably I'm going to write this one more term as n squared times square everything here, divided by 4. 6 will be cancelled. So n times n plus 1 times 2n plus 1 plus 5 over 2 times n plus 1. Okay. We need 1 over 4n. But there is n plus 1 also a common factor in every single term. So I'm going to take carefully 1 over 4 n times n plus 1 as a common factor. So you have to pay attention closely here. In this first term, if you take out 1 over 4 n times n plus 1, you will be left with n times n plus 1, right? Because if you multiply these two, you will get n square n plus 1 whole square. Plus, in the second term, if you take 1 over 4 n times n plus 1, n times n plus 1 will be gone, but there is no 1 over 4, so you need to put 4 times 2n plus 1. If you multiply these two, the 4 will be gone, you will get this term, right? Okay. And in the third term, if you take 1 over 4 as a common factor, you will get 5 over 2 times 4, n and n plus 1 will be gone. So if you multiply these two, the 4 and 4 will be gone, you will get 5 over 2 n times n plus 1, you will get this term. Now that's all, you just need to carefully simplify this. So it's going to be 1 over 4 n times n plus 1 times, here open the bracket, n square plus n, open the bracket, 8n plus 4, this is going to be 10. So it's 1 over 4 n times n plus 1 times n square plus 9n plus 14. And then factorize the quadratic. You can use your calculator to get the two values. You go to the quadratic, put the coefficients 1, 9, 14, that's 7 and 2. 1 minus 7, so 7 and 2. So you can write it as n plus 2 times n plus 7. It looks exactly like this, right? That's all. It's a 5-mark question. Now let's look at part B of the question. Hence determine the value of this. Okay. In part A we were given this actually. Maybe I'll copy the result here. Okay, I have copied the result here. If you compare them carefully, this is r plus 1, r plus 5. If r is 20, it's going to be 20, 21, 25. That's what you have here. Plus 21, 22, 20 plus. This is 21 plus 1. This is 21 plus 5, right? This is 40, 40 plus 1, 40 plus 5. It's basically what I'm trying to say. It's sigma r plus 1, r plus 5, but the value of r is from 20 to 40 if you look at the series carefully, right? If you replace r by 20, you're going to get the first term, r by 21, r by 22, etc., etc., the last term, r by 40, right? So to use this result, in this result, A is 1, B is 2, C is 7 from previous part, right? To use this, it has to be, the limit has to be r is equal to 1 to n, not from some random number. So if you have r is equal to 20 to 40, it's same as subtracting, taking r is equal to 1 to 40 and minus r is equal to 1 to 90. So if you subtract, think about it in a real the number line. This is 1 here, 19 here, 20 here, 21, 22, 40 here. We need this 20 to 40. So you subtract 1 to 19, right? So that's what I'm going to do. Why we are writing this way? Because the lower limit has to be 1 to apply this form. So I'm going to write it as r is equal to 1 to 40, r times r plus 1 times r plus 5, minus sigma r is equal to 1 to 19, r times r plus 1 times r plus 5. Now let's use the result from here. It's 1 over 4 n times n plus 1, n plus 2, n plus 7. So in this case 1 over 4, n is the upper limit, n times n plus 1 times n plus 2 times n plus 7 minus, here the upper limit is 19, that's n, 1 over 4 n times n plus 1 times n plus 2 times n plus 7. That's all. Calculate this value. So what I'm going to do, I'm going to write one more step. 1 over 4 times 40 is 10 times 41 times 42 times 47. That's a single term, plus 1 over 4 times 19 times 20 times 21 times 26. So let's do it uniformly. Instead of write, I'm gonna write it as 1 over 4 times 40. So I'm gonna calculate these values first. 40 times 41 times 42 times 47. 3237306. 1 over 4 times 3237360, right? Yep. Sorry, not plus, minus, right? Minus 1 over 4 times 19 times 20 times 21 times 26. 2074 So let's calculate this now. 1 over 4 times 3237360 minus 1 over 4 times 207480. That's the final answer. 757470. 757470. Again, read the question always when you get the answer. Did they mention anything else? Nothing. They just want you to find the value. So this is the answer. That's all.